All right, day 2, we're going to talk about distributive property as well. The difference is we're going to have 2 variables now and some factors that are fractions and various coefficients. So we're going to have to know what those words mean. Okay, what is the factor? So from yesterday, we know that the factor here is 5. Okay, I'm going to answer these parts when I get my final answer. Okay, so we're going to use the same method as yesterday. So I'm going to distribute, I'm going to give 5 to the 6x. So it looks weird, but this is true. 5 times 6x. It's subtraction, so subtract. Don't forget to give the merchandise to the second store. So 5 times 8, 5 times 8. Okay, if you notice, the only difference from yesterday to today is that now this is a number. Instead of being 1, it is now a different coefficient other than 1. So how do you think you're going to get this? Well, it's still subtraction. I know this is 40. And what do you think this answer would be? Well, yesterday we did 1 times 6, so that was 6x. We had 1 times 7, which was 7x. So it's the same thing here. You would do 5 times 6, which is 30, and just tag along Mr. X. Here's the reason why, because that's really what it is. 5 times 6 times x. So that's 30x minus 40. That is your final answer. Why is it your final answer? Because these are not alike. This has an x and this doesn't. So they are not alike. So how many terms do I have? Subtracted from addition or subtraction, I have 2 terms. My terms are 30x and negative 40. And what's my coefficient? 30 is your coefficient. 30. Your constant is negative 40. Okay. Same concept here. When we had a problem like this, remember when it was in a 9 in the back, you had 2 methods of doing it. One of my methods is just to move the factor to the front here instead of being in the back. You don't have to. So the factor is 9. So I'm giving 9 to the 3 and a 9 to the 6. I'll use a different color here. So 9 to 3a. So we're distributing 9, 3a. I have addition. Then I'm going to give 9 to 6b. So 9 times 6b. This example has 2 different variables. Fine, no problems here. Okay, so this is, again, like how I did up here, this is really 9 times 3 times a, which is all multiplication. So this is 27, and then with a attached to it, because you know when they touch the multiplication. And then this is really 9 times 6 times b, which is 54b. Are these the same letter? Are these the same variable? No. So guess what? That is the answer. That is the answer for this one. You cannot add those together. Why? Because this is an A and this is a B. Can't add these together because this is an X and this doesn't have an X. They are not alike. They don't look alike. Okay, in this example here, how many terms? Still addition or subtraction. So I have 1 term, 2 terms. So my terms here are 2 terms, which is 27a and 54b. I have 2 of them. This is what I'm asking here. What's the coefficient? Oh, it's the number in front of the variable. I have 27, but I also have another variable with a number in front of it, so it actually has 2 coefficients. Do I have a constant? Are either of these terms never ever going to change? No, they're always going to change. So if I asked you, is there a constant in this example? The answer is no, there is not one. Was there a constant in this example? Yes, because this one will never change. So the constant here is negative 40. Okay, so all we're doing is same thing as before, just distributing it. Okay, last type of examples is with fractions. You know how to multiply fractions. You have to keep in fractions because some of these will repeat. So same concept. I'm going to, this is my factor, so I'm going to factor or distribute this out to this one here. So this is half of 10b minus, because this is minus, and then I'm going to take half of 6. Think about what I'm saying. Half of 6. It's multiplication. So if you remember, whole number, we could put them over 1, right? So this is really 1/2 times 10b over 1. So this would be 10b over 2, because 1 times 10 is 10, 2 times 1 is 2. Or you can just think about it, what's half of 10? That's 5, and tag along Mr. B. That's it. That's all. Subtract, subtract, subtract. Half of 6, what's 1/2 times 6 over 1? That's 6 over 2, which is, half of 6 is 3. Can I add those together? No. Why? This has a B, this does not. How many terms? 1, 2 terms. Coefficient, constant. Just let me go over some of those vocab. Okay, let's look at one where it's a little bit different here. Same thing. 2/3 times 9x. So I'm going to distribute out. This is our factor. I got to give it to both terms or both stores. So 2/3 times 9x over 1. You might as well just put it like that. And this is over 1, this is over 1. So if that helps you do it there. And then I'm going to give 2/3, and then I'm giving 2/3 to 18 over 1. Because 18 divided by 1 is still 18. So how do I do this? Well, I multiply the tops. So 2 times 9 is 18, and then I tag along Mr. X. 3 times 1 is 3. Okay, and then 18 cut into 3 parts is 6, right? 18 divided by 3 is 6, and then tag along Mr. X. Bring down your plus sign. 2 times 18 is 36 over 3 times 1, which is 3. 36 divided by 3 is 12. Don't forget your variable, because if you forget it, you might make a mistake. There you go. Can I add those together? The answer is no. This has an X and this does not. Okay. So there's more practice here. The only other thing that I could have is a problem like this. I'm going to use a fraction again. Let's do 2/5 times, let's say, I don't know, 5x plus 10y, but minus 20. How would I do this? Okay, this is an easy problem to do. All you're going to do now, I don't have 2 stores to give it to. I have 1 store, I have 2 stores, I have 3 stores to give it to. So these are all over 1. So I'm going to give 2/5 to 5x over 1. So 2/5 times 5x, and that's over 1. And then, so it's addition. And then I'm going to give 2/5 to the second store. I got 2 stores now. So that's 2/5 times 10y over 1. But I got another store to go to, store 20. It's subtraction, so we have subtraction here. So I'm going to give 2/5 all the way to 20 over 1. So 2/5 and 20 over 1. So here we go. All you do is what we did before. 2 times 5 is 10. And then I have an x over 5 times 1, which is 5. 10 cut into 5 pieces is 2. Tag along Mr. X. Addition, addition. 2 times 10 is 20. But don't forget Mr. Y. 5 times 1 is 5. 20 cut into 5 pieces is 4. And then bring down the y. Don't forget your variables. This is new, so you will forget to bring those down. And then you're going to give 2 times 20, which is 40. 4 1 times 5 is 5. No variable this time. 40 divided by 5 is 8. Almost wrong, wrote the wrong answer. So this is more of a challenge problem. So how many terms do I have this time? What is my coefficient or coefficients? And do I have a constant? Okay, this is the answer. Why? Because you can't add an x with a y, and you can't add x with nothing, and you can't add y with nothing. So in order for me to add these would have to look alike. They all have to have the same variable, or they don't have variables, or whatever. So how many terms did you come up with? If you said 3 terms, you are correct. And what are your terms? There's 3 terms. It's 2x, 4y, and -8. Coefficient. Do you have more than one? Do you have more than one variable? Yes, you do. So the number in front of the variable, the number in front of the variable, because these answers are going to vary. So you have 2 coefficients, the number 2 and the number 4. And 8, -8, is that a constant? It is. Because -8 will never change. It's going to stay the same. So there you go. Here's one of more of the challenging type problem. Okay. All right. So if you have any questions, come back into Zoom, and I will see you tomorrow. Maybe if I could stop this thing.